the integers from 1 to 16 are placed in 16 circles in the figure shown right here, with each number occurring exactly once, and so that the sum of the 6 numbers around each hexagon is s. What is the greatest possible value of s? So what we have this 16 circles. We put 16 different numbers in them from 1 to 16. And what we want to make sure that if I add the numbers around each hexagon here, or here, or here, or here, I get exactly the same number. That number we call s. Okay? And we ask, well, can we have such an arrangement? Well, actually, they're asking us a question: what would be the arrangement when we have the maximum value of s possible? Okay. The way we're going to approach this problem is, instead of just looking at 1s, we're going to add the values for all these circles. We're going to add 6 values here, plus 6 values here, plus 6 values here, and 6 values here. Total, we're going to get 4s. Okay. But the thing is, it's easier to work with 4s than with s. And now, if we can show some arrangement that gives us the maximum value of 4s possible, that arrangement is going to give us the maximum value of s as well. Okay. So now, let's look what's going to happen if we get 4s, if we add all this 4 hexagons. Okay. Well, we find that some of the circles, the numbers, we're going to see once in the sum, and some of it we're going to see twice, some of it we're going to see 3 times. For example, this blue things in the middle, we're going to see 3 times, because if we add this hexagon numbers, we're going to see this number, we're going to add this number. Then if we take this hexagon, we're going to add this number again. And when we add this hexagon, we're going to get this number again. So we're going to see this number 3 times. Now, these red numbers are going to be seen twice in the sum. Okay? White number is going to be seen once, right? So if you look at 4s, we can represent it like this, where those pound signs are numbers. There are 16 pound signs that represent 16 different numbers. And you see 2 numbers we're going to see 3 times, 2 numbers we're going to see 4 times, the rest of them we're going to see once. Okay? And now the question is, if I have 16 numbers, 1 through 16, how do I get the maximum value for this? Well, the answer is this. So you want to multiply by 3 the biggest numbers you have. In this case, it's 16 and 15. You want to multiply by 2, the following biggest numbers, kind of. You have 14, 13, 12, and 11. And then whatever you have left, you're going to just use once. In this case, you're going to have the maximum sum. Okay? So this is what we want to have. We know this sum is the maximum if I have numbers distributed like this. Numbers from 1 to 16. If we add them up, we get 248. In this case, s would be 62. Okay? But now, what we did here is really, we didn't really look at this picture when we calculated these things. We are not sure yet that whatever we calculated here is actually possible to create here. Okay? All we did was said, well, I have this arrangement, I have this number that calculated this way. I have 16 numbers from 1 to 16. What is the possible number to get? Well, the biggest possible number to get is 248. Okay? Or for 1s is 62. Okay? But we didn't show that this kind of arrangement possible. So the last thing to do is actually to show that arrangement when we have things like this is possible. The arrangement when these blue guys are 16 and 15, when these red guys are 14, 13, 12, and 11, and the white guys are numbered from 1 to 10. So it's not very difficult to try and find the arrangement. There are multiple arrangements possible, and this is one of the arrangements I can have. So I'm putting 15, 16 here, 14, 13, 12, and 11 in these four spots, and then I'm distributing the rest of the number in a way, so you have to distribute those in a way that each hexagon gives you 62. Okay? It's not difficult. You can try, you can find your own arrangement. So we just proved that the maximum possible value of S is 62.